So thanks for coming back inside and joining our talk. We both work for the biggest bank in the Netherlands, and we have been practicing site reliability engineering for a year and a half, a little bit longer now. And we want to share with you what site reliability engineering actually is, why we started doing it, how we do it, and what we're actually working on, including some technical demos of what we're actually producing for our internal customers. So this is us. As you can see, we explored Malaga a little bit, went to the market, very nice. So my name is Janna. I'm an IT chapter lead within our organization. That's a job function in which I both do work for the team, engineering work or other work, and I'm also responsible for HR duties of some of the team members. Before this, I worked as a business manager to a CIO, and I worked as a dev engineer on credit cards and debit cards backend systems.
Hi, my name is Toby Vonzell. I used to be an ops engineer for the mobile banking department, and I used to be responsible for all online services for ING. And since 1.5 years, I'm the product owner for the site reliability engineering team. So as a product owner, I decide what we do as a team, not how we do it, but what we do.
Yeah, so a little bit more about ING before we head on. So we are a global financial organization, and we're active in quite a lot of countries all over the world. We don't really have the same way of working as ING Spain, just to make that a little bit clear. We'll be talking about the domestic bank in the Netherlands, so that's banking for retail customers. We have over 8 million retail customers, and that's actually quite a large number because the Netherlands has about 16 or 17 million inhabitants in our country. Within our country, we mainly act as a digital bank. We have a lot of branch offices as well for quite some for lending services, mortgage services, and so on. But a lot of people actually use our mobile banking app and our internet banking platforms. We reach quite high numbers with that. We have a long tradition in terms of technology, so anything from mainframe HP non-stop to Polymer and Java, we have everything in between. So quite an interesting landscape for us.
So one of the biggest challenges for us is availability, and that's the most important thing for us site reliability engineers. And to show us why we do site reliability engineering, we created this graph for you. What you see is are two bars. The one on the left says something about the availability of doing a payment within the website, so the internet banking channel. The one on the right says something about doing a payment in the mobile banking app. The bars are divided in three. The lower part, the green one, says something about the percentage of availability. The middle one, the orange one, says something about unavailability due to change. And the upper one says something about the unavailability due to incidents. And so as you see, we have an average in 2017 of 99.72% of availability on our internet channel, and it's far not good enough because we have regulators and the demand from us that we have higher availability, and we would like to have availability figures like Google is talking about, like the 4 nines, the 5 nines, but well, we're not there yet. So we started, let's click here. We started site reliability engineering, and I think it's a good idea to tell you something about what site reliability engineering is in general. Well, this cool guy, Ben Trenner, came to Google and started to take on the challenge of operations, and he did so by doing site reliability engineering, or by starting site reliability engineering. And basically, site reliability engineering is doing operations with a software engineering mindset. So you software engineering, well, you solve your operations by doing software engineering. And within our team, we try to cap the software engineering, well, the not software engineering work to 50%, or to at least 50%. And well, we try to do all things by software engineering. And what we try to do is work on reliability topics and reducing toil, so all the manual work that all teams have to do. When we started, we needed to find out what to do, and we searched for challenges related to reliability to solve. One of the first things we've seen is that we had a centralized monitoring solution based on Grafana and Elk, and it was not performing very well. So teams couldn't really rely on it for the real-time monitoring. The other thing was that the teams were not in control of this monitoring solution. So they couldn't fix it, so they couldn't rely on it, and they weren't responsible for it, so they didn't use it for the real-time monitoring, which is quite bad if you're doing DevOps. Then we had a centralized alerting solution, and it worked like a basic system of if an application was failing, it would send out an alert to a chain of applications until it ended up to a master control room, which is like a NOC. And well, at the time, the operator at the master control room received the alert, found the work instructions, and in the work instruction it will tell something about, well, call the responsible engineer, this is the phone number. And it took an average of 69 minutes before an alert ended up at the responsible engineers. This was only measured for our major incidents, so for our business critical functionalities like doing a payment, listing the balance, viewing transactions, stuff like that. And we measured our availability, as you've seen in the slide with the availability figures. But we do so by measuring with black box monitoring, and that's okay, because black box monitoring will tell you something about if your services are working for your customer or if they don't. But the teams are not able to see any availability of their applications by white box monitoring. So they don't know anything about how available their application is. I told you about the alert, and that it took an average of 69 minutes before it ended up at the right engineer. But they did arrive at the right engineer, and the engineer was going to work on it. Are there any people here on call, just like I was? Great. So you know how it is to be waking up at night by a page, right? And well, that's horrible, but well, once you have the alert, you wake up, you say sorry to your partner who's next to you in bed, and then you start working to solve the incident, and then you're kind of proud because you solved the incident, customers are happy, and everybody's cheering. And then you come to work the next day, you will tell your colleague, and he will tell you, well, I had the same thing last week. And this happens a lot within ING. I was involved in a post-mortem in January, and this post-mortem was about an incident, and the incident was that customers weren't able to see their balance on the 2nd of January. And well, you could imagine what happens if you're a customer and you had like this New Year's Eve, and then you wake up on the 2nd of January, and then you want to see what the damage is, and then you look at your cell phone or your mobile phone, and you see your balance. Well, you don't even see your balance. Well, you panic. So that's pretty bad. And but this wasn't the first time we had this incident, and it wasn't the first time we had this incident because of this root cause. So we don't have any habit of learning from previous incidents, and if we do learn from previous incidents, we don't apply the changes that solve the root cause. So we're not a learning organization yet. And then the worst thing for our engineers. We have a lot of toil. We have regulators, and the regulators demand from us that we're in control of our risks. And to prove our regulators that we're in control of our risks, we write documents. We write documents that we promise that we do backups. that we promise that we could restore them, that we promise we reach some kind of availability. And we have to do this all the time, and all of our engineers of all DevOps teams need to write these documents, and well, that's not a really big turn on for them. So we see this as a challenge for the SRE team because we are software engineers and we like to automate, so we like to reduce toil. So we saw that as a challenge for us.
Yeah, so a little bit more about our way of working and what our organization actually is like. So we can tell you a little bit more later about how we actually solve these problems. So within a domestic bank, we work in the Spotify model, so we work in tribes. In these tribes, there's BizDevOps squads. So tribes are centered around functionality groupings. So we have a tribe for securities, or a tribe for mortgages, or payments, stuff like that. I think there's about 18. We have about 3,000 employees working in tribes, of which I think about 1,700 are engineers. And we are SRE team supporting all those people. We are a team of 8 right now. As we said before, I'm the chapter lead, so I am responsible for hiring and firing, and well, that has not happened yet, but it's part of the job, but the way of working, and Robin is responsible for what we're actually working on. So we actually quite like being outside of all the tribes. This means we have less layers of management, which we tend to like. But it also helps that we have a core focus on improving reliability. Because it can happen that if you work for a tribe and you also have the purpose of delivering reliability, then your tribe lead might one day say, oh hey, this customer feature is much more important and we need to get it done like right now. And sometimes improvements regarding IT operations can be forgotten when stuff like that happens. Maybe you have the same experience with that. So we have a single focus, and that's really powerful. So a little bit more about what we're doing. This is the service reliability hierarchy, which is in the Google SRE book, which you can find online for free. Google it, it's really good. So this hierarchy actually demonstrates everything that goes into making your product reliable. And it starts with monitoring at the foundation, because if you don't know if your service is running or not, you cannot improve anything about reliability otherwise. So you start with monitoring. Once you know if your service is running or not, you can do some incident response, and then you can start learning, doing postmortems and root cause analyses, and it goes all the way up to product, which represents doing reliable product launches at scale. So we actually like to use this hierarchy to explain people within our organization what we're actually working on. There's been quite some reliability initiatives within ING before, because we have to deal with regulators, but also because if something, if our internet banking is down for like a longer period of time, say a couple hours, we actually end up in the national news. So that sucks. And that means that people associate the word reliability with quite some other initiatives that were a little bit more old-fashioned. So we use this to explain what SRE entails, and we like to use it to explain our products as well. So our main priority is engineering. So we build tooling to help the BizDevOps squads, and we focus on Prometheus right now. That's because, as Robin mentioned, there was a lack of white box monitoring within ING and a lack of alerting going directly to teams. So that's why we picked up that topic. With Prometheus, we are working on alerting via SMS and chat ops, and email. The white box monitoring part, and traffic modeling, which we will show you a little bit about later. We also work on delivering Mattermost as a platform. This is a ChatOps application. So ChatOps is doing your operations centered around a chat application. Slack is a really well-known one, but we're not allowed to use that because it's hosted in the US, and we have some restrictions about usage of those types of software, unfortunately. So Mattermost is an open source version of the same of a similar product. We also help BizDevOps squads with post-mortems, as Robin explained. So we do have a major incident management process, and they do root cause analyses, but as we mentioned, the learnings aren't always shared in a broader sense. So they do send out the root cause analyses to people in a mailing list, but they're not always, the learnings are not always formulated in a way that other people can learn from them, and the process is not always blameless. So we try to introduce that type of culture and that way of learning from your mistakes. Sometimes we are asked to help if a team has reliability issues that they cannot fix themselves, so then we do some consulting. We also work on stuff that's related to all layers in the hierarchy. So we also educate others about what SRE is. We do large-scale demos for people to join. And we also develop training materials. So what we discovered is that when talking about monitoring within our organization, people are like really obsessed with tools. So you start talking about monitoring, and the first thing is like, oh yeah, but we have ELK, or we have some other type of tool, we have Dynatrace Gomez, something else, and they're not always aware of the purpose of that tool. So I did this demo at a department about Prometheus. I actually explained white box and black box monitoring, and then afterwards someone came to me and he said, oh, looks really cool, but we just spent so much time putting everything into ELK. And I was like, but it's a completely different tool and completely different purpose. So that's how we found out that we actually have to do something about educating people about monitoring, its purposes, and other reliability topics. So we created some materials for that and are giving classroom trainings. We also help if other people want to start with SRE teams. There's some teams popping up over the organization, so we gave them some advice. We have community meetings, guild meetings, and we collaborate with people outside of the Netherlands on SRE. And a good thing to mention is that in the Google SRE world, the SREs are also on call, so they take over the responsibility of operations for a service, and we do not do that. BizDevOps teams are responsible for their own build and run, partly because of sizing issue, with 8 people against 1,700 other engineers, but also because we spend a lot of time on getting everyone responsible for their own services with DevOps. It was quite a journey, getting everyone to go on call for their services and responsibility for build and run. We do not want to take away from that, and we cannot know never know how to fix an issue in someone else's application better than the responsible team themselves. So it would not benefit me time to repair at all. So a little bit about what we're actually working on in terms of engineering. So our purpose is to reduce time to repair through engineering, and we do this by improving our monitoring with Prometheus and introducing ChatOps. So a little bit about Prometheus if you didn't go to Bridget Star. So we have Prometheus as a solution. This is a time series database. It also has an alert manager. It's an open source product, and you can read about it on at prometheus.io. Prometheus actually scrapes metrics from endpoints. So this is a very basic layout, and we'll go a little bit into what we do with it in more detail. So it scrapes metrics. Then we use Grafana for dashboarding, as the UI for Prometheus is quite simple, and Grafana is much more powerful in terms of dashboarding. And we push alerts to SMS, email, or ChatOps. And now Robin will tell you a little bit more about what we like best, engineering.
Yay, engineering. So, yeah, one of the first things when we set up Prometheus, well, Prometheus is kind of easy. You download the binary, you install it on the machine, and it runs, right? But we know when you start a new service within ING, you have to do all this paperwork all over again. So we knew when we started with the new monitoring tool that we got all this paperwork, and we wanted to have Prometheus for the teams so that they had their own Prometheus and their own configuration. But we knew if we were going to do that they had a lot of paperwork to do. So we needed kind of a setup where we gave them everything without all the effort for the teams itself. So we wanted to make it very attractive to use this awesome monitoring tool. So basically what we deliver is a tool, tools and metrics. And the tools is what we call the Reliability Toolkit. You could onboard within our team, with our team, and then we will give you a set of machines with installed Prometheus, Grafana, the Alert Manager, the Model Builder. And the Model Builder is an application that's capable of creating models out of any Prometheus metric and turn the model into a metric into Prometheus again. So you could compare two metrics with each other, one with the actual data and one with the models, like an expectation model. But I will show you some screenshots which is really helpful to understand it. So the teams will get machines from us with all these installed tools, and we have this basic set of configuration for them, which give them like a working solution with working alerting systems. The only thing they have to do is to configure it and to create their own querying, so they could create their own alerts. That's the only thing that they have to do. They don't have to configure anything, and they don't have to write any documents. And we give every team right now its own Prometheus server. And we do this because we want to learn from all these teams. We want to learn how they use Prometheus. But the servers remain in our control. And by doing that, and by turning it into the Reliability Toolkit, we had to do the whole paperwork stuff, the writing documents only once, and that's for us, and the teams don't have to bother anything. So about the metrics. When we started creating the Reliability Toolkit, we knew it was going to take us a long time. It took us a year or so. So we wanted to have like this quick win. So what we did, well, within IG we use Nginx for reverse proxy of most of our APIs. And with the Nginx access logs, we have a lot of information about the applications. So we created this quick win. Nginx is sending its access logs to Kafka. What we do, we consume the access logs, we turn them into readable time series for Prometheus, and then we read them in Prometheus, and then they're accessible for our Grafana instance, and it's accessible for every team. So we create like a standard dashboard, which I will show you next to this. We create this dashboard for teams, and they have like this overview of their applications from an Nginx perspective. So this was like a quick win for us, because the other thing we were capable of is having this overview of all these applications running just behind Nginx, and while having incidents, we could see the impact on every single application. The other thing we did was implementing the client libraries from Prometheus into frameworks. Within ING, we use frameworks for creating APIs, for example. And by implementing the client libraries into the same frameworks, we gave teams the possibility to have like this default set of metrics when they use the framework. So it is like, while using frameworks, you get all these benefits, including metrics you could read with Prometheus. So they didn't have to implement anything in that application except for using the frameworks, which most teams already do. And we put some effort in implementing call D on every virtual machine running within ING, and then using the right Prometheus plugin to expose the VM metrics on the machine itself. So right here you see an example of an incident with one of our network switches, and we could see the impact right away on every application. And before we had this application, before using Prometheus, we weren't able to have a really fast impact analysis. We spent a lot of time in war rooms to analyze the impact, and now we see it right away. So this was really a quick win for us.
Yeah, is it legible? No? Okay.
Not the letters, but
It isn't.
On the left, there's percentages. It might be good to know. So it goes all the way up to 100. And on the bottom, there's time. Below that, all the horizontal stripes, they're applications. For the demo purposes, it doesn't really matter what type of application is in there. Just a lot of applications from behind Nginx. So you see that there's actually quite a high percentage of errors when everything started going down. And that we have a total overview with about, how many applications do you think these are? About 30, 50?
More or less.
50 applications sending out errors all at once.
Yeah, in the middle part, this with just lines with colors, but you could see the plants.
Yes, this is going to be more of a challenge even.
This is even more of a challenge. Yeah, we have to do a presentation with this analog connection. So it's USB-C to this analog connection, and it's, well, this is the result. This was supposed to show you like this dashboard for teams, where you could see one team having all these applications, and you could see the errors of them and the alerts that were sent out to them. So basically, a templated dashboard for teams ready to use, and that's what we want. If they are going to use the Reliability Toolkit, they will get templated dashboards. They will get templated alerts because, yeah, well, VM metrics are more or less the same everywhere, so we know a little bit what to look at. And so we'll just give them the templated dashboards and the templated alerts, so they don't have to think about it, right? But I don't think you're able to see it.
Unfortunately.
Yeah.
Okay.
Yeah, and this was the coolest one.
We still make something out
Yeah,
of it.
we can make something out of it. So this is a green circle. This is a red circle. This is a yellow, orange circle. Okay, yeah. What we tried to show you here was the graph of our model builder. We created models out of the traffic on all applications, and we put the models back into the Prometheus. So within the graphs, what you see is well, basically two lines. One with the actual traffic. And the other one, and most of the times it's the yellow one, but it's hard to see like this. The other one is the model, and we compare the model, so like the expectation of the traffic to the actual traffic, and this creates the possibility for teams to have this kind of anomaly detection to create an alert if something's well, totally different from expectation. This is not always possible because we have like these payment batches and customer are waiting for like their salary, and it's not always the same day, the same time, or the same day in the week. So sometimes it's kind of hard. So we advise not to turn any alert on like these peaks when the traffic is a lot higher than expected. But when you have like this decreases, like this dips in traffic, most of the times there's something going on and you want to know it. But you could also use it for any saturation kind of metric, like your disk space, memory, CPU usage, those kind of things. When you have like this things you could expect and something is really, well, an anomaly.
Yeah, so we would like to wrap up with some of our learnings after 2 years, well, a year and a half to 2 years of doing SRE. And we'll be talking about people, process, technology as a way to distinguish between topics. So what we have found out is that if you want to do this type of work, that it's really important that people in your team have a good reliability mindset, that they're open to learning, that they want to embrace failure and learn from failure, and that they're also that they can deliver this type of sentiment in a constructive way to other people. It's really important and really helps with the reputation of your team. Within ING, there are multiple SRE teams. Not all of them have like a PO that's just does that line of work, so they have chapter lead and PO combined a lot of the times. But what we see is because we are responsible for dealing with the entire organization of 3,000 people, that we actually needed a product owner like Robin, so that the team can focus on engineering. And also because we still have to, since we are an internal sort of IT for IT team, we also have to spend some time on promotion and spreading SRE love, as it were, to make sure people know about us and want to use our products. So we recommend having a product owner. In terms of hiring, consider what mixture works well for you. For us, internal hiring really helped out because we pulled some people in the team from departments that were not represented in our team. So our most recent joinee is someone from the payments domain, of which we had no representation in our team. That helps out, but we also had an engineer for mobile who was really well known for his reliability mindset and working on monitoring join us, and that made our team so much more powerful. So I quite like that, but external hiring can of course bring in new knowledge. We also have a sort of SRE internship, which is quite nice. We're trying to see how that goes. So we have this girl on our team who is spending 6 months with us, and she has learned a lot about monitoring and reliability, and now she will go back for a couple months to her old team to help over there and spread that knowledge there, which wasn't there in the beginning. So that's really cool. So we hope that next time we do a talk, we can share how that went. In terms of process, we actually did a pilot before starting with SRE. So there was a pilot of 6 months to see if this way of working fitted well. I think sometimes people forget that you can actually try something like this before actually implementing it. So we really recommend to see if it works for your organization. For us, it was really, as I mentioned, that there are a lot of connotations with the word reliability within our organization. So for us, it was really important to have like a vision and definition on what SRE is. Also because some other teams within the organization feel like that SRE can sometimes be used as like the sort of controlling board on reliability, that if a team does not have its reliability in place, then we will come in and be a little bit more negative as opposed to offering them cool products. So for us it was really important to define what SRE means to you, and we defined a roadmap together as a team, which was really nice to do as well, because that you can have everyone represent the team and not just the product owner. We learned a lot from visiting conferences, doing company visits. So we actually visited the air traffic control center to learn how they deal with incident learnings, which was really cool. So sometimes think outside of the box in case of these topics and see what you can learn from others. There's great online resources about SRE, lot of accounts, newsletters, everything. Prepare to spend time on promoting SRE, explaining your purpose and your tooling. And what we also like to do is, as a team, we've grown a lot by doing something that we call beer o'clock. So that's Thursdays at 4. We noticed that in Malaga it's Thursdays at, what was it again? 1:20 during lunch. Of course, it's also allowed to not drink beer. But we actually, when we started doing that, we came together with a lot of other SREs from in the organization, and we exchanged some thoughts there as well. So we really like doing team activities and making the team stronger. Technology, as Owen mentioned, making it very attractive for others to use your tooling. I think the next talk is going to be about this topic as well. So stick around if you're interested in this. Take away pain for teams. Oftentimes teams are surprised when they start to use our tooling about how little they have to do. We're really happy at any time they give that reaction. And like Robin said, incorporate your tooling and widely used frameworks, find quick wins. Also, as Robin mentioned, productization takes a lot of time. If you want to deliver your product well, it took us about a year. Don't underestimate. And consider scalability and ownership in tooling strategy. So that's it for now. Are there any questions?